Hello and welcome to Tartu. We are today visiting our office here in Tartu and we're talking with Hando-Laur about spatial data, so the data about houses, streets, weather and so on. So we're gonna go to our office, which is here in the company hub historical building, in the same building with Billy Joe's Jazz Bar.
Welcome, Hando, and we're going to talk about spatial data today. So you are an expert in it, and maybe as a start, you can maybe explain what is spatial data to our viewers who don't know really about it.
Well, spatial data is data which has information about events or objects within specific location, meaning that we know where something is or something happened. And by having this spatial dimension means that it's very valuable data for businesses, for example, offering even greater insights for different decision-making processes and analysis and so on. Of course, due to the complexity, it means that it has its challenges. It might require some specific solutions for processing data, storing data, but it doesn't always mean that you need to have some very complex new program. Even many modern BI solutions like Power BI and Tableau are capable of processing spatial data and displaying it.
Can you give us any examples? Like, is it, you mentioned digital twins, or is it houses? Is it, I don't know, trees, bushes, or?
It's everything. Just simple address is a spatial data. We have a name of the street and the number of the building, which is tied to some single location, but also everything you see on Google Maps, roads, points of interest, everything is spatial data. Weather forecast, where exactly is temperature 5 degrees today, and so on. So the possibilities are endless. And for business, of course, where are our customers, where are suppliers, which is the best option for distribution, where are the best roads for our cars, trucks, so on.
And compared to ordinary data, ordinary data is also dynamic, but how is the dynamics of the data usually handled, or is it handled? I mean, like cars moving on the street all the time, weather changing, is it like different than compared to, I don't know, sales data or something?
Well, you still need some specific sensors. We all know GPS, which is essentially a sensor for getting live location data. So this is quite often used for monitoring your fleet, for example, if you are maybe a recycling company, or your workforce. It's easy to send some message to workforce that in this location you have a, say, issue with the power grid. Go there, workforce goes there, fixes the issue, and then marks it fixed.
Okay, but you have worked quite long in this area. How many years?
Well, more than 8, I would say.
And maybe you can tell us some interesting stories or examples of what you have done.
Well, my journey started in academia. After graduating, I spent some years there doing some research. And quite interesting topic for me was modeling past landscape and environmental changes. But later on, I have mainly worked with government institutions. And maybe one of the most interesting projects was I participated in a project with one government agency, which in essence didn't have any proper data management solutions or plans or even data storage. So it was a long project starting with business analysis just to understand what data there is, who are the users, what are the requirements, both in-house and out-house from out-house users. Then creating new data model, creating all the data quality and data governance rules, creation of data repository, central data repository, so there would be a single source of truth, and later on working on different applications where data could be accessed, or services where data could be shared with other partners.
So you started basically from scratch there.
Yeah. So it was challenging, but it was really an interesting project with, I would say, substantial results.
Mm-hmm. Is it better to start from scratch, or is it better if there is?
It depends, because when you start from scratch, you really have to spend a lot of time on analysis, because stakeholders, for example, often don't even know what are the possibilities, or how to make things better, or if there are really strongly separated silos, they don't even know what other department or person is doing. So it takes time, a lot of time at first, but by having this relatively empty canvas, it's probably a bit easier to create a good working service and solution.
Okay. Can you give us a good examples how private persons are using spatial data now, or so that everybody would kind of feel how they are using?
Well, it's all around us, starting from food delivery services, which we quite often use, navigating using Google Maps or Waze, even weather forecast or doing sports. Our activity trackers use spatial data, both when we are analyzing our training performance. Besides distance, we also, when we're running, need to include elevation data, how much we run uphill, how much we run downhill. So it's all around us.
And obviously this amount of data is growing and growing, isn't it? Or if all the trackers are all the time monitoring where all the people are, and does that how do we use it, or how do we make it usable, this type of data?
There is abundance of data, of course, and in some cases it's most likely that there is too much data. But of course, vendors are learning and getting feedback from users, so there are more user-friendly interfaces where there are nice displays of your data, which aggregate data to display, I don't know, your monthly averages, whatnot. But of course, there are issues and challenges. Privacy is the main example, because as we are tracked constantly, then it's very easy to see where we live and where we work and so on. So yeah, it has its challenges.
When it comes to spatial data compared to ordinary data, and by ordinary I mean, for example, companies have sales data, or they have financial data, or they have HR data, so data about their employees, then this can be usually displayed in a table, or maybe like relations, but when it comes to spatial data, the amount is so much bigger. Is it more challenging to visualize it? Or what are the aspects what you have to look into that?
Yeah, it can be challenging, because the data also have geometrical information included. I don't know, if you have a building, you have the shape of the building, for example. But in some cases, we can simplify. For example, if you want to see all the customers who are in Germany, for example, you don't have to display the shape of the country. It's just enough to show the name, although the location information can be stored as a geometry in the database.
So it depends on the use case. Yeah.
Yes.
Okay. And when it comes to organizations and not private persons, and starting to use spatial data, then you brought out like two strategies that companies have. Sometimes or organizations want to solve all the problems at once and with one solution. Or sometimes they build a solution per use case. And I think both ways could be correct in a certain situation, but probably there is some sort of a balance in these. So either one big thing that solves all, or many small things that everybody has a specific solution. How do you balance between these strategies?
I think first of all, it's important to understand what you actually need. Doing everything at once really looks very tempting, because it's quite easy to get the impression that if you do it, you have maybe a substantial initial investment. After that, everything works. But quite often, organizations is quite big, and it's quite hard to get a good overview what is actually needed, get enough input for different stakeholders. So quite soon after finishing the project, there will be additional needs for further developments, changes, and so on. On the other hand, when you are doing just small developments for every specific case, then the overhead will go through the roof, because every solution has its own nuances and its own requirements, and in the long run, it will be quite expensive. And I think the balanced solution in most cases is the best solution, because as I mentioned before, people initially even don't completely comprehend what's possible. So just starting by creating a centralized data repository, implementing some initial data quality, data management rules, finding owners for data, so there will be responsibilities. And after that, when you have most of the data in more or less acceptable condition, you can start with some first test cases which have perhaps higher impact. And these proofs of concepts, salvage, give good indication to people what can be done. It's easy to get some initial feedback, gather some ideas, and after that, it's possible to move on with longer steps. But the important thing is to be agile and take your time.
It would be good to have some sort of a central repository or the data in one place, but then services on top of that.
Yeah.
That also. I just was thinking that as a private person, we have all our spatial data in different apps, more or less. Of course, some Google maybe somehow connects it, but we have food delivery in one app, our running and other exercise in another app, navigation in a third app, and then we might have an app for our a land we own or house where we watch see this. And wouldn't it be nice if it all would be like a virtual world where we have all our data in the same thing? Or is it necessary? I don't know. Weather is in a fifth app and so on.
Maybe for a private person, the amount of data is still somewhat limited compared to the different companies, because one data point which many applications private persons have is your home location. So I think most people wouldn't like to have it anywhere, but we are quite eager to share it somehow for convenience.
Absolutely, yes, of course. I mean, that's the first thing in Google Maps or Waze that they ask, where is your work, and so you can navigate. Yeah. So we are sharing our data sometimes just easily and without knowledge. Second thing you mentioned when it comes to organizations and their data strategy or spatial data strategies, should they buy out-of-the-box solutions or use open source or do their own development? How to choose between these strategies?
Well, out-of-the-box solutions might be easier to implement at first, because they have a strong development team behind them, and they usually implement well-known standards and so on. the downside is that they aren't very flexible, so it's not too easy to integrate into these solutions to existing workflows. So on the other hand, open source solutions offer more flexibility, but of course, although the initial investment might be smaller because you don't have to pay license fees, there is need for maintenance, development, and so on. So for flexibility reasons, open source is probably better. And I would also emphasize that the community for open source software is incredible. So if organizations are willing to make investment in people and in development, then this is certainly probably more flexible strategy for the future.
So you would at least recommend to have a look at open source possibilities,
of course,
before buying anything. Yeah. And of course, buying something is not a bad option if it fits your needs and it's faster probably than configure.
Yeah, of course. I'm not saying that proprietary software is useless or not needed. It can be very good for some organizations. It quite often out of the box offers integration between different environments and solutions. For example, it's very easy to integrate mobile solutions with desktop solutions and server solutions. So it can be very useful, of course.
Mm-hmm. But now the final question. So how do you see the future of spatial data? Where are we going with all this? What are the most important things to follow?
Well, as mentioned before, the volume and complexity of data will increase because the data will be even more integrated. So we have even more information about any specific point. We will have new data gathering solutions. We have better satellites. We have UAVs gathering data and so on. So more and more data processes will move into cloud. The development of 3D digital twins will continue, which will be also a very interesting development. There will be, of course, challenges. How will the legislation change? Because, as we know, legislation is quite often lagging quite far behind the technological development, and covering all the privacy and security rules is quite challenging.
Mm-hmm. So one thing is certain: there will be much more data.
Yes.
Will we soon be in a world where everything is like in the digital twin, and we could like project the real world into a virtual world?
It kind of can be, because, for example, for some bigger structures, business buildings or supermarkets, there are very detailed models. There are intelligent systems which use sensor data, for example, to drive the heating system, ventilation systems, just to keep the costs down and use resources where they're needed, and shut the processes down where they're not needed. So, yeah.
Mm-hmm. Okay, so thank you. This was very interesting. So in the future, we will definitely see more data. Yes. And it is a good thing. It helps us to optimize costs, not waste heating up rooms that are empty.
Yes.
Thank you, Hando.
Thank you.